Good day, guys. Today we'll be discussing about division with non-restoring, and just remember this: division can be performed in two different procedures by the digital circuit. One is with a non-restoring, another one with restoring. So before stepping into the procedure, key points are like the Booth algorithm, we'll be using a register called accumulator Q and M register to process the entire division with non-restoring. And remember this particular point: whenever we are performing the division, accumulator and M register will be n plus 1 bits. Say for an instance, if we are using a 4-bit decimal number to be represented as a binary number, and we are using a 4-bit, then the accumulator and M should be have a n plus 1 bits, that is 5-bit it should have. So we'll be looking into the example that makes you more closer in this. So the steps in the division with a non-restoring are: we'll be performing shift left, and if the MSB of the accumulator is 0, we'll be performing A minus M. If the MSB of the accumulator is 1, then we'll be performing A plus M. And this is quite important, and even it's an interview question, that if a division is performed using a non-restoring, that time too the restoring procedure will be done after the respective clock cycle has been over, but it will be done only if the MSB of the accumulator is 1 after all the clock cycle has been over respectively. So remember this point. I repeat, the restoring procedure will be done in a non-restoring division method, but that will be done only if the MSB of the accumulator is 1 after the clock cycle has been over. Now we directly step into the example. So we go with a number like 14 divided by 3. So here the dividend is represented in the register Q, and that is 14 over here, and the divisor is represented in the register M, that is 3 over here. So now Q is 1 8 plus 2 12, then right. Oh, this is the binary representation for the Q, and divisor, that is M register, is 3, but we know n plus 1 bits for accumulator and M register, so keep it in that mind. So 5 bits 3 representation is 0 0 0 1 1, and now similarly M dash we have to make it, because we know A minus M will be performed as A plus M dash. In that way, M dash is nothing but there's a a 1's complement of M, that is 11100, and 2's complement is plus 1, so just add 1 0 1 1 1. So we got as M dash is equal to 11101. That's it. Now we step into the procedure. We have a operation, we have a accumulator, we have M, right? Remember this. So initially we have a Q and then M, we have a Q and then M. So operation initialization. So remember, accumulator to have 5 bits and Q to have the dividend, that is over here is 1110. It is represented as a 4-bit, right? Even if it is represented as a 5-bit, there is no big deal on it. So an M will be 5-bit representation of the 3, that is 00011, and M dash also we just have a note on it, so that became a 111011101. Now the first step, right, the first step 1, that is shift left. So what happened in the Booth algorithm, you might remember we had performed a right shift, but here we'll be performing a shift left. So from the Q register, the shift left is going to happen. So the first bit will be the blind bit. So the first bit will be the blind bit, and we are making a 1 shift left. So, and this one, right, this one will be going to the accumulator and write the remaining bits, right. It's simple, it's as simple. So now if the MSB of the accumulator is 0, we are supposed to perform A plus M dash. So what is the M dash? 11101. So 11101. Now just do a binary addition, 0 over here, 1 and 1 1 1. And if this MSB, after performing A plus M dash in the accumulator, MSB is 1, then the blind bit of the Q will become a 0, and just write the remaining bits. Just remember the step, right. Now the step 1 has been over. Now perform the shift left. So again, now the blind bit, that is Q naught, is 0, that is blind bit, and just do a shift over here, shift left, and this one comes to the accumulator. Just write as it is. Now MSB of the accumulator is 1, so we'll be performing A plus M. So what is M? It's 00011. Just do a binary addition, 0 1 0 1 0 1 0 1. So 0 and this one over here, which can be ignorant. Even it is a 5-bit storing accumulator. Now we are getting a 6-bit, so a 1 will be ignorant, right? So again, the resultant accumulator MSB is 0, so the blind bit has to be written as 1, and just write the remaining over here. So we have done with step 2, this is 2, we are moving to the step 3. Again, while performing the shift left, the Q naught will be blind bit, and that will be a 1 shift. This one will be over here, and the remaining, right. So now again the MSB of the accumulator is 0. We'll be performing A plus M dash. What is M dash? It should be 11101. 11101. Just do a binary addition. Now we do know the MSB of the accumulator is 1, so the blind bit will be 0, then write the remaining bits. So we done with the step 3, we are stepping into the step 4. So as we do know, shift left, and Q naught is 1, so it's a blind bit, and we are making a 1 shift left. So this 0 over the accumulator, and write the remaining 0 1 1 1. Now again MSB of the accumulator is 1, so we'll be performing A plus M, so which is 000 1 1. So 1 1 1 1 1, right? So right there, if the MSB of the accumulator is 1, so now the blind bit will be 0. So this is step 4, and now we do remember one important point what I have seen in the beginning, that after the 4 clock cycle, because here we had the dividend 4 bit, so 4 clock cycle has been over. If the MSB of the accumulator is 1, we'll be performing a restoring. So just remember this, restoring. So restoring has to be done with the M, and the M is 000 1 1. So this is the M. Just remember, we will be restoring the M with the last obtained quotient that is available in the last obtained bits that is available in the accumulator. So remember this, just perform an addition. So 0 1, so that became 1 and 1 carry, and again 0 1 0 1. So 1 will be carry and that will be ignored. Just remind this. And again the Q register will be retained as it is 0100. So now this will be the final result. We got A is equal to 00010, Q is equal to 0100, and accumulator holds remainder, Q holds quotient. So what happened now? So accumulator 00010 is nothing but 2, quotient 0100 is nothing but 4. So remainder is 2, quotient is 4. What we actually taken 14 divided by 3. So 4 3s are 12. So the remainder will be 2. So remainder, quotient. So this is how division with a non-restoring has been completed, and we have done one restoring step in the non-restoring division. Just remember, it's quite important, and it is done only after the last clock cycle has been over if the accumulator MSB is 1, or else we'll be not doing that restoring step in the non-restoring, as we had a 1, that is MSB is 1 in the accumulator after the respective clock cycle has been over. That's it. It's simple. Just keep